Topic 5, 12, exploring behaviors of implicit relations. So, do you guys remember when you had to do implicit differentiation? Alright, so, it's supposed to end up being negative 4x over 9y, so we're just going to review how we're actually going to get that. So if we start with 4x squared plus 9y squared equals 36. If you differentiate with respect to x, that's where you have that extra dy dx put in when you do that, right? So the derivative of 4x squared is 8x, yes? Yeah. The derivative of 9y squared is?
18y dy dx.
Yes, 18y dy dx, and then of course the derivative of 36 is 0. So then if I manipulate it so I get dy dx by itself, I get dy dx to be, move the 8x over, so I get negative 8x, divide by 18y, I get 18y on the bottom, and then of course if I reduce it, then I would get exactly what they're saying that you should get, right? Yeah. Alright. So, note that dy dx equals 0 when the top is 0, which means x is 0. Okay, so that would be where the horizontal tangents are. So do you see you have a horizontal tangent there, and you have a horizontal tangent there? Yes? Note that it's undefined where the bottom is 0, which means y is 0 in this case. And where y is 0, that corresponds to the vertices of the major and the minor ellipse. So the 4 vertices are the critical point of the implicit relation. The ellipse has horizontal tangents at 0, 2 and 0, negative 2, and the vertical tangents at negative 3, 0, and 3, 0. Right? Okay. So that just shows you kind of when you're using a relation that has x's and y's mixed up, that you can still do the same kind of things that you're used to doing. Okay, so now we're going to analyze it using this first derivative. Okay, so this is where it gets maybe a little complicated, but not really. Okay, so in quadrant 1, between 0 and 3, do you see that and 0 and 2 in the y, dy dx is less than 0, meaning it's decreasing, right? Okay, so you can see it visually on here, but do you notice that if we have dy dx is equal to negative 4x over 9y, and if we plug in numbers in the first quadrant, so like for instance, positive 3, like just pick a random point that's on that equation, and more than likely they'll give you a point to test or whatever. Like they might say, test 0, 2 or something, or test, 1, whatever. So you're going to plug it in, and again, all you're looking for is the sign of it, right? So if x is positive and y is positive, no matter what you put in the first quadrant, because all x's are positive and all y's are positive, do you see that dy dx would be negative because of this negative sign that's located in front of it? So that means it would be less than 0 in quadrant 1, which means if the first derivative is less than 0 in quadrant 1, it is decreasing, which visually you can see it's decreasing here. Okay? Yours isn't in color, so you may want to highlight that that's what we're talking about. Okay, so then if I look at dy dx in the third quadrant, where, okay, so again, negative 4x over 9y. What happens in the third quadrant? Well, in the third quadrant, x is negative and y is negative. Do you see? Yeah. So no matter what I put in here, I'll have 3 negatives, which makes it, I put greater than 0 there, hey? It should be less than 0 in the third quadrant. If I do this, and that's where it's decreasing as well. Do you see that? I'm going to do positive in a second. But does this make sense to you what I'm doing here? Okay.
Yeah.
All right. Okay. I'll scroll up. So now we're going to look at quadrant 2. Quadrant 2, if I plug it into dy dx equals negative 4x over 9y, what happens in quadrant 2? Well, quadrant 2 is negative x's, positive y's. So do you see this will be negative and that will be positive. So I have two negatives there, which means it is positive. So greater than 0. Do you see what I'm saying? And then if I go, so that's in quadrant 2. And if I go dy dx equals negative 4x over 9y, can you read my writing? Again, in quadrant 4, I have positive x's and negative y's. So this is positive, this is negative. I have two negatives, which means it's greater than 0 in quadrant 4. So that means in quadrant 2 and 4, that's the intervals that are increasing. Do you see what I'm saying?
Yeah.
Okay. Okay, so now we're going to do a different relation. Okay. We have 3 times x minus y equals 4 plus 3 cos y. And we're going to show that dy dx equals that. So maybe I'll give you a moment to actually try 3 times x minus y, find the derivative of that, to see if you end up getting 1 minus sine y. Okay, I'll pause it, and you can pause it too to try it. Okay, so let's just try this. So the 3, it's up to you if you want to multiply the 3 in.
I did, I think it was stupid.
Well, it might be less confusing if you multiply it in. So just in your head, you know this is 3x. So the derivative of 3x is just 3. And then the derivative of minus 3y would be minus 3 dy dx. Okay? So then the derivative of 4 is 0. The derivative of 3 cos y.
Negative 3 sine y dy dx.
Yeah, negative 3 sine y dy dx. Okay, so you got that far.
dy dx is confusing me.
Okay, so now we got to get the dy dx is on the same side, right? So I may move this over to that side. So 3 equals 3 dy dx minus 3 sine y dy dx. All right. So then if you factor out the dy dx, actually you could factor out the 3 dy dx. Actually, sorry, you don't want to. You don't want to. You don't want to. You just want to factor the dy dx and then divide that out, right? So I'm just going to write dy dx on the other side. So I'm going to get 3 divided by 3 minus 3 sine y. Does everybody see what I did? Okay, so now I'm just going to divide the 3's out of there because I can reduce it to 1 over 1 minus sine y. So that's exactly what I was supposed to show. Okay? So note that dy dx doesn't equal 0. Does everybody understand? Because the top, there's no variable on top, so there's no place where you would get a horizontal tangent. Now, dy dx is undefined when when 1 minus sine y equals 0. And of course, then you'd use your trig, and you know that when you're doing your unit circle here, sine y would be 0.
3 pi over 2? Or just pi?
Sorry.
Or, I mean, pi over 2 and 3 pi over 2.
Yeah, it's going to be, pi over 2 and 3 pi over 2. And I said that wrong. I said sine y equals 0. Sine y equals 1 at pi over 2 and 3 pi over 2 in every rotation. So that's essentially the pi over 2 plus 2. We used to say 2k pi, but anyways. So that means there's vertical tangents at every pi over 2. What you can't really tell where it is because the scale on the x-axis is going up by 1. But pi over 2 is 1.57, right? So, which is weird
You
because.
kind of just look at this.
Actually, it's when y is pi over 2. So you can see where pi over 2 is here. I didn't do that very good, right? Yeah, you can just see. But you may not have a graphic calculator to see this very well. But so there you go. Okay, so now we're going to analyze where it's increasing and decreasing. Actually, now we're going to do, concave concavity. So that means we have to do the second derivative. Okay. So, if dy dx equals 1 over 1 minus sine y, how am I going to find the second derivative? How am I going to find the second derivative?
Wouldn't you just have to find the derivative of the bottom? Really?
Well, yes. So, but you can't just do that and stick it on the bottom. You got to actually raise it to the top, right? And do the chain rule. So does everybody see this is going to be 1 minus sine y to the power? Yes, yeah.
Okay, that's what I mean.
Yeah. I didn't know if that's what you meant or not, but yeah, we can't just
More or
ignore
less, yeah.
stuff. Like we have to work with what we have. So now you may not have seen the second derivative of dy dx, but you're ddxing it again, right? You're ddxing, so that means you're getting d squared y over dx squared. Okay, because you're ddxing that side. So now you're ddxing here, which means you're going to get an extra dy dx, right? So, chain rule, right? Negative 1, 1 minus sine y to the power negative 2. And then the derivative of the inside, the derivative is 1 is 0. The derivative of minus sine y is?
Minus cos y dy. Yeah.
Yes, cos y dy dx. Okay, now I don't think you've seen this yet, so this is a new step. You can't have d, like the second derivative and the first derivative mixed. Now tell me if I'm wrong. Have you seen this before? Where now what you're going to do is you're going to substitute your answer for dy dx in there.
We have to do that for a concavity.
You have to do that for concavity. Okay,
Concavity
so
is all of it, that stuff.
yeah, so it's good and it's bad, whatever. But so I'm going to show you this next step, and it's kind of in a, like I'm surprised it actually comes up. Usually, maybe they'll, if they give you the second derivative, they give it to you. But what happens is, what you're doing here is you're going to take this and sub it in for there so that you have a final answer there.
Yeah.
So d squared y over dx squared, or the second derivative, is negative. Well, so I'm not going to put a negative because a negative, do you see, is a positive. The 1 minus sine y squared is going to go in the bottom, right? And so then this is going to be cos y, and then this is going to be
So would
1
cos y go
over
on the
1.
bottom? Right?
So sorry?
Change, flip it, and then once you multiply that in, you just put a cos y on the bottom? and-
Yeah.
Okay.
No, the cos y is going to stay. This is going to slip to the bottom. So my final answer is going to be cos y over 1 minus sine y to the power 3. Okay? Everybody good there?
I hope.
You hope. Okay, so now we're going to look, originally, so this is a little bit harder now to do because this has to do with our y's, right? So we basically have to put in numbers to see if we're going to get positive or negative. So what's going to happen here? Let's pick some numbers for y. Y is, again, we're going with pi's and pi's over 2's and all that stuff. So where does cos y, like if you think about the unit circle, right? Cos is our x coordinate, right? Where does it become negative?
2 and 3.
Yeah, so it's in 2 and 3, okay? That's where that top would then be negative, okay? Quadrant 2 and 3, yes. And then sine y, because this is to the power 3, we do have to watch out for stuff, right? Okay, so what would make this concave up means I need to have positive, right? I need to have positive. So 1 and 2, watch there, that would be 0 undefined, right? So I would get 1 and 2. What did I put for 2 and 3? That was negative there, right?
Yeah.
I should have actually put it's positive in 1 and 4. And then sine y would be positive in 1 and 3. So the overlap is basically 1 again, except where we're going to get...
Two?
It is 2, sorry. My writing is so bad. So then, so we have all of quadrant 1, which would be 0 to pi over 2. Does everybody see this range right here? That's quadrant 1 for the y values. Now, why is it positive here? So that's going into that part, right? So then let's think about this for a second. Going into negative pi over 2. So if I take something like cos of, I don't know, what's a value here? Say negative pi over 4 or something like that. That would be positive. And then this would be less than 1, so it'd still be positive. Do you see what I'm saying? Root 2 over 2. You see if you divide it by 2, it would be less than 1. Yes? So then that would still be positive. So this whole part here would be then concave up, because d squared y over dx squared is greater than 0 there, which gives me concave up. Okay? Let's scroll this up. Now we're going to look where it's concave down. Concave down, again, I'll write out the derivative. D squared y over dx squared is equal to cos y over 1 minus sine y to the power 3. So if we look at values of our unit circle, if we look at values in our unit circle, don't be nervous about, oh, how am I going to do this without a calculator and stuff like that. Don't be too worried. It'll be, if I ask you this on a test, it'll be something that you can plug numbers in pretty easy, like I did the first example. You know what I mean? So I just want to show you what's happening here in the first quadrants and stuff like that. Okay, so you can see visually here that it's concave down between pi over 2 and 3 pi over 2. So it looks like it's here and here, right? So again, I'll show you why. Again, cos is, again, concave down means it's less than 0, right? So we're looking for negative. So sine is positive here, except that when it gets to, what do you get when you get 3, like the biggest one would be 1, right? So then you get 0. So that, again, it wouldn't include where sine is 1, right? It wouldn't include sine as 1. Or, I guess negative 1, it wouldn't matter, right? Okay, so cosine is negative in this quadrant, in the second quadrant, right? And it's negative in the third quadrant. And you might say, well, wait a second, isn't sine negative in the third quadrant? But because you're going 1 subtract a negative, you actually get a positive, right?
Yeah.
So no matter what, it's really, we're looking at the cosine there, right? Okay, so you can see that's where it's going to be cosine net. Okay, so let's now do some questions where it would actually be something that you would be requested to do. Okay, example 1. Example 1. The points. No, I was just showing you why it's concave down. Because the reason why I'm not asking for you to actually do anything there is I was just proving that between those two that's concave down. Okay? So I'm showing you the application, so now we're actually going to do some numbers here. Okay, so here we go. Example 1. F of x is a function that dy dx equals 3x minus 2y subtract 8. If f of x contains the point 2, negative 1, which of the following best describes 2, negative 1 on the graph of y equals f of x? Now if you look at all these terms here, how would I figure out relative minimum, for instance? What would have to happen?
It's where it changes from, you do a number line of the critical points and the endpoints.
Yeah, so dy dx would equal 0, and it would have to go from
Negative to positive.
negative to positive. What about relative max?
Positive to negative.
Yeah, dy dx would equal 0 at that point or whatever, and it would have to go from positive to negative. What would happen at a point of inflection?
You have to find the second derivative.
You'd have to find the second derivative, and what would have to happen?
The concavity would have to change, or the...
Well, the point of inflection, it would have to change signs, right? And
And the
dy,
first derivative
and
or
the
the
second,
second one?
the second derivative would have to be 0, and it would have to change signs in the second derivative.
I can never remember.
And then of course none of the other ones, none of the above. Okay, so let's hope it's the first one, because then we don't have to go through all this, right? Okay,
Oh, I thought we'd like to do
so
all
they're
these.
giving you the first derivative. They're giving you the first derivative. Okay? So let's find out what the first derivative is when you have 2, negative 1 there. Okay? So that means we're plugging the x and the y in for the x and the y up there, right? So it's going to be 3 times 2 minus 2 times negative 1 subtract 8, which is 6 plus 2 minus 8 equals 0. Okay. So, what's faster, to do a sign diagram to see if it goes from negative to positive or positive to negative, or find the second derivative and just see what the sign is for that point?
Second derivative.
I think the second derivative in this case would be the fastest way. So let's find the second derivative. So that is d squared y over dx squared equals, what would be the derivative of 3x? 3. Subtract 2 dy dx, which then would be 3 subtract 2 times 3x minus 2y minus 8. Does everybody see what I did there?
Yeah.
I'm substituting the dy dx in there. So I get 3 plus 16 would be 19 minus 6x minus, or plus 4y, is that right? 19 minus 6x plus 4y, yes, okay. So now we're going to find the sign at 2, negative 1. So we're going to plug 2, negative 1 into the second derivative. If it's positive, it's what?
Concave up.
Yes, it's concave up, but what is it, a minimum or a maximum?
Maximum.
Minimum.
Minimum. If the second derivative is positive, yeah, so it's, yeah, you gotta think about that for a second. Okay, so this is gonna be 19 minus 6 times 2 plus 4 times negative 1. So 19 minus 12 minus 4 is 19 minus 16, which is 3, which means it's greater than 0. So that means it is a minimum. So that means we're done. Okay? Are we good there?
Yeah.
Yay, okay. Next one. The points negative 1, and 1, negative 5 are on the graph of this derivative. Which of the following must be true? True. Okay, which of the following must be true? Okay, so how am I going to do this? It's the same process, right? We're going to have to plug her in and then see the sign of the second derivative to see if it's minimum or maximum. Okay. So let's try negative 1, negative 1. Okay? I'm just going to go with the first one and hope that we find it on that first one. So that means dy dx would equal negative 1 squared plus negative 1, which gives me 0. So we know it's a critical value. We're on the right track. Yay. Make sense? Now we're going to find the second derivative of this. So d squared y over dx squared is equal to, what's the derivative of x squared? 2x. What's the derivative of y? dy dx. So I'm going to rewrite that with my dy dx in. So that's going to be 2x plus x squared plus y. Does everybody see what I did there?
Yes.
Okay, so now I'm going to find the sign at -1, -1. Okay, so d squared y over dx squared is going to be 2 times -1 plus -1 squared plus -1. So this is -2 plus 1 minus 1. So we get -2. So that means it is it's a max. So is that one of our choices? It is, C. We know it's a max because
It's
the
a
second
negative,
derivative
the
is
second
negative,
Oh.
That's just separate.
right? Second derivative negative means it's concave down. Concave down means it's a max, right?
Yeah.
All right.
So it's C.
Okay, yeah, so if that wouldn't have worked in the previous example, you'd have to go on to the next example to find the choice. And then, of course, if you had time on a test, you might want to just play through all the choices anyways. But if you don't have time, you got to be very wise on your time, right? You need to just get the first answer, maybe put a little question, not even a question mark, just go check back if I have time and go back. Like, you got to get faster at your, your answer here. Okay, here, consider the curve whose first derivative is dy dx equals yada yada. Determine the concavity of the points between 0 and pi. Give a reason for your answer. Okay. Concavity is which derivative? Second. So the first thing we have to do is find the second derivative. So that's d squared y because I'm ddxing.
Should
Right.
we change the way they wrote it?
Yes, we should. Very good.
3 times 3 plus the cos squared to the power of 1.
Yeah. Absolutely. That would be way, way easier. Okay, so now we're going to find the derivative. So this is the chain rule, right? So the -1 gets multiplied by the 3, so we get -3. The inside stays the same. Yes? And that's to the power of -2. Then you got to find the derivative inside. The derivative of 3 is 0. The derivative of cos y is dy dx. And again, we're going to substitute dy dx back in, right? So first off, we're going to have this at the bottom. So 3 plus cos y to the power 2. This is a -3 on top. Oh, I'm going to make it a +3 because a negative. 3 sine y on top. And then my dy dx is a 3 over 3 plus cos y. So does everybody see this 3 plus cos y can slip on the bottom again?
And
So-
would you multiply the 3 from the
Yes, yeah. So we're going to get 9 sine y over 3 plus cos y to the power 3. Okay, is everybody good there?
Yes.
Okay, so let's think about sine y first off. Look at our, this is 0 to pi. Does everybody see?
Yes.
What's true about 0 to pi?
Sine is negative. Sine is positive.
Sine is positive no matter what. So I can put right there, that is positive no matter what in 0 to pi, right? Okay, so now we have to determine the concavity.
You just remove the 2 for that.
Concavity. So cos y is what? It's positive in here no matter what, so I don't have to, so from here to here, it's going to be positive no matter what in that. Okay, now we're going to go to the second derivative. Cos is negative. Now, because we're adding 3 to it, it's always going to be positive. Does that make sense?
Yeah.
Okay, so that means this is always going to be greater than 0. And so what's our rationale here? Because it does say give a reason for your answer. So I'm going to say sine y is always positive 0 to pi. And then we can say, although cos y can be negative in pi over 2 to pi, since we add 3 to it, denominator will always be positive 0 to pi. So then our final answer then would be, because since d squared y over dx squared is greater than 0 in 0 to pi, concave up.
Okay.
Yes? Concave up.